Good afternoon, folks. My name is Pablo Quiroga. I'm a director of product management here with Qualys. And today we're going to be talking about how to identify, analyze, prioritize the risk of your software supply chain by continuously analyzing and scanning vulnerabilities within your SBOMs, software bill of material. How many of you, raise your hand, had to deal with Log4j vulnerabilities like a couple of years ago? Anyone? So at Qualys, we did a research on which we took around 8 million servers, and we analyzed them, and we found that 79% of the software on these servers is open source. And we also saw that 90% of first-party software, that is homegrown applications developed by your own teams, contain open source software. This is not a surprise, but what is surprising is that more than 40% of these software components, open source software components, have risk. That is like an exploitable vulnerability. So that is like really huge risk. And if you look at the impact of this, right, when Log4Shell happened, 1 in every 2 organizations spend more than a month actually remediating Log4Shell. So if you look at the typical timeline of identifying the risk and then remediating these open source software vulnerabilities, if you look at the typical timeline, right, when you start, you identify the vulnerability, you get notified, you have to start aligning resources. For Log4j, it was very complicated. You had to actually run deep scans or run scripts on your machines to identify these components and their vulnerabilities. So you start assessing the scope on where you need to launch such deep scans in your environment. And the teams were still learning. So after 7 days, the community was still struggling to identify which software applications, both commercial and open source, have packaged a vulnerable version of Log4j in their applications, right? So as new updates came in, as a team, you had to update your scripts, update the scope of where you're launching your scans and your assessment. By day 14, teams started detecting these vulnerabilities. And if they were able to maintain a list of critical assets on their environment, they were starting to at least prioritize based on the criticality of their assets. This is if they maintain a up-to-date inventory of their assets and which ones were actually more critical to their business. And a lot of manual analysis on, after detecting Log4j component, you still, as a security team, you had to work with IT to identify, is this Log4j part of an off-the-shelf application, like a third-party application that I deploy on my servers? Is this something coming from my internal team, the DevOps team, that have provided a solution or a software internally? So a lot of manual analysis. And then you have to trace those applications, who are the owners, and then talk to them, right? So by only after, by a month, what we have seen is the average remediation time was 17 days. That is after you identify the vulnerability, after you're able to identify the assets, the software, right, you were starting to patch. And what we have seen also is that after 40 days, 30% of these vulnerabilities were still unpatched. So there's a big issue. And as you can see, basically the time that it takes for teams and the effort that it takes for teams to actually identify, prioritize, and remediate is very long. So if you look at some of the reasons, right, the key reasons are there's no software catalog available to them to understand which are those components, which are those potential internal or external or like third-party software or internally developed software that are affected by these open source components. There's a limited risk assessment at runtime. That means that you have to actually target your scans very deeply, and that assessment is not usually done continuously by the teams. And then there's a lot of manual remediation, especially if you don't understand the business context of these assets and these applications. And more than anything, this is a really reactive approach, right? And then we understand that software supply chain risk management must be instead proactive, and it must be continuous. So one of the key things that can help us do this is the software bill of materials. So CISA defines the software bill of materials as an inventory of components and dependencies on software. This is the list of ingredients that go in a software. And SBOM has not been, it's not something new. It has been around for 10 years, but in the last 2-3 years, it has accelerated. In fact, in order to do business with the government today, as a software provider, you have to provide your software bill of materials. So we only see this accelerating even more across the industries. Because it provides basically transparency about what is packaged in the software, and then about the vulnerabilities. So even if that is accelerating, there are still some gaps in the existing solutions, mostly on the DevSecOps. Like your development teams are focused on scanning your repositories, your code repositories, and one of the issues is basically correlating or aligning that with what is happening in your production environment. So when software is drifting, for example, you can't really check that. On the other side, at runtime security, the good part is that it already covers major technologies like Java, Python, etc. So the tools that are, and in fact, Qualys has recently developed our runtime security for these technologies. So our agent is able to scan automatically your files and your entire file system to detect these components and these vulnerabilities. But one of the issues still is, how do I know what is the third-party or first-party software application, and what is the business context around that? So still the remediation time is still going to take a long time if you're only able to detect these components, the vulnerabilities, but you're not able to identify which application is responsible and who's the owner for those applications that you have to go fix. So there's a lack of integration between your the DevOps and the runtime security. So this brings me to Qualys SBOM risk analysis. What it does is it helps you build a single repository of your SBOMs across your first-party and third-party applications. For third-party, that is off-the-shelf third-party software. For most of the common software packages like Elasticsearch or Tomcat, it automatically gathers the SBOM. It automatically maps that to your existing software inventory that you're collecting within our cybersecurity asset management solution. And for your first-party software, your internal developed apps, it supports integration via API to ingest your SBOMs in the most common formats like SPDX and CycloneDX, so that it integrates that from your DevOps to your runtime security. What this does is that it gives you the ability to continuously find these components and the software. You can search for these components and immediately see what are the applications that are actually mapped to these open source components. And within the Qualys TruRisk platform, we correlate this information, we detect the vulnerabilities, and we correlate that information with 25 plus sources of threat intel. So what this does, it helps you actually prioritize those vulnerabilities based on the actual impact that they have on your environment. For example, if these vulnerabilities are currently being exploited, if they're trending if there is a POC for it. So it brings all of that information, and it helps you actually identify which of these vulnerabilities matter the most, so you can fix them first. So this helps you really bridge the gap between your DevOps team developing your internal applications and your runtime security. And it also helps you better scope the assets that you have to do deeper analysis with the software composition analysis. And this really gives you a continuous supply chain risk management. So let me give you a quick demo. So this is going to be integrated with our cybersecurity asset management, where we basically collect information about your internal assets as well as your external assets. You build a complete inventory of all of your assets and all of the software. So now teams can come here directly anytime there's a new vulnerability, a zero-day vulnerability, or news about a software component that is part of a vulnerability, and you can search for it. You can search and you can understand which applications are actually using that component. What are the different versions of that component? And of course, you can fine-tune that search. In that case, was like version older than 2.16. You can search that, find your assets. I'm going to click on a server here and find out all the context that we're gathering about that server, right? Where it's located, what is some of the business context, what is the owner. So we are integrating with the CMDB also to pull an Active Directory to pull this information about your business context, so you get to know more information about your asset. If I look at the software, again, we are enriching that inventory with information such as which of these versions are end of support. And then you can basically pivot into your components here. And if you see here on the right-hand side, we are mapping that to this is an internally developed application. So this has been mapped. This is my reporting services, 1.101. It has these components. I can see the dependencies on them. The list of vulnerabilities, again, with our Qualys detection score, which brings the threat intel and helps you actually bubble up which are those vulnerabilities. Even if, let's say, the CVSS score may be like an 8 or even a 7, it will bubble up because it's basically bringing all of that threat intel to apply that information. So it's to help you prioritize which are those components, the vulnerabilities, the critical vulnerabilities within that SBOM, and what are all of the assets that are actually part of this solution or this application, right? As I mentioned, we are integrating, bringing the business context, such as who's the owner of the asset, who supports that asset. Is this asset part of a critical business application, like my banking app in this example, which is in production, is operational, it has a business criticality 5 out of 5. And we utilize all of this data that we're gathering about the asset, all of the context, the vulnerabilities, and additional context such as unsanctioned ports. In this case, for example, this is an external asset with RDP port open. It has end of support software. You can create policies where you define what software is required on these servers, like Zscaler, for example. You can define unauthorized software. For example, in a database production web server, I don't need Firefox, right? So you're always trying to fix vulnerabilities on Firefox. Instead, you can define a rule, and we'll flag that, and we'll include that as part of your risk. So all of these different contexts is part of the risk scoring algorithm within Qualys. So now that, and again, now that you have, let's say your team has fixed some of those vulnerabilities, and of course, all of this happens on the API, but I'm just showing you here on the UI. You'll basically import a new version of that SBOM, supporting the CycloneDX and SPDX formats, and then basically scope where that SBOM is applied. In this case, my banking application. And now what we do is, once we have that SBOM, we're continuously doing vulnerability assessment. The next day, a new vulnerability could have been detected on one of the components that is used across one or many of your applications. So that will be continuously get assessed every day, and then you'll basically get your risk score and identify those vulnerabilities. So now I can track all of my assets, all of the external assets, critical assets, all of my critical business applications, their SBOMs, their risk, and I can slice and dice by who supports these applications, what are the components, a breakdown on the licenses, the categories, which ones are databases, which ones are, and then understanding also which ones are end of life or end of service today, which means that there's no patches, or even plan ahead of time, like 3 months, 6 months ahead of time, if any of these components will be end of life and end of support, right? So we make it very easy for you to track that in an ongoing basis, and of course you can also create alerts and send notifications to Slack channels, or send an email based on rules that you can configure with the same query language that we support in our platform. So just to conclude, what you can achieve with this. So what are some of the business benefits of doing this approach, right? So we can reduce our detection time from what we have seen, 14 days. Teams were struggling to find out what are the asset scope, what are the applications. You know, you're already doing that. So in a day, you already have all of that information continuously, and then you can reduce the time take to actually triage and prioritize and understand who owns these applications, because you have that data immediately. So we believe that you can reduce your end-to-end response time from 31 plus days to something between 3 and 7 days with this solution. As I mentioned, this is part of our cybersecurity asset management, which builds a complete asset inventory with all of your hardware, operating system, software information across internal assets, external assets, internet-facing assets, and then it detects these security gaps. Here we have a QR code. You can scan that. You can sign up for a 30-day trial free of charge, and then start building your inventory, the context, and everything around your assets. Thank you.